Welcome to Two Projects. In this video, we are going to explain the project Netflix Movies Recommendation System using content based filtering and cosine similarity. Before diving into the execution, let me give you an overview of the project. So, in this project, we will be implementing a recommendation system for Netflix movies using content based filtering and cosine similarity. First, we'll understand what is content based filtering. So, content based filtering is a method that suggests movies based on their unique characteristics such as genre, cast, and plot, rather than considering the preferences of other users. This approach gives recommendations to individual users by analyzing the features of movies they have interacted with previously. Coming to cosine similarity, it is a mathematical technique used to measure the similarity between two movies based on their feature vectors. So each movie is represented as a vector in a high dimensional space with each dimension corresponding to a specific feature. Cosine similarity calculates the cosine of the angle between these vectors, indicating how closely related the movies are in terms of their features. That means it measures how alike two movies are based on genre, cast, plot, etc. If two movies share many similar features like the same actors or storyline, they'll have a high cosine similarity score. So, this is how it works. The importance of content based filtering and cosine similarity lies in their ability to enhance user experience on platforms like Netflix. By providing personalized recommendations that align with users' preferences, these techniques increase user satisfaction and engagement. Now, talking about traditional methods like collaborative filtering methods, they often face a problem called the cold start problem, where new items or users don't have enough data for good suggestions, resulting in less accurate recommendations. Content based filtering tackles this problem differently by looking at the unique features of items. It suggests similar items based on their characteristics, not just on past user behavior. So, this approach means it can still provide reliable suggestions even when there isn't much interaction history available, making recommendations more dependable and satisfying for users. Now, we'll look at the workflow. So, the project starts by using the Netflix movie dataset, which contains details about movies available on Netflix. First, exploratory data analysis, that is EDA, is conducted to understand the dataset structure and learn about the movie attributes. Next, data undergoes data pre-processing to clean it up. This involves removing any inconsistencies, missing values, or irrelevant information to ensure the data is accurate and reliable. Clean data is very important for precise analysis and generating accurate recommendations. After cleaning, feature extraction is performed to identify meaningful features from the dataset, such as genre, cast, director, and synopsis. So, these features are essential for representing movies and calculating similarity scores between them. After that, a function is created to process the textual data from the dataset, which generates a textual soup representation. So, this soup combines multiple movie attributes into one text format, making it easier to analyze and compare movies. The textual data is then transformed into numerical vectors using techniques like count vectorizer. So, this conversion enables mathematical operations and similarity calculations based on the textual data. Once the numerical vectors are obtained, cosine similarity is computed between movie vectors to measure their similarity based on their feature attributes. This similarity measure helps identify movies with similar characters. Finally, a recommendation function is developed. So this function takes into account the similarity scores calculated earlier and generates a list of top rated movies that are most similar to the user's preferences. These recommended movies provide users with personalized suggestions based on their preferences and the characteristics of the movies. And the project utilizes Flask, a web framework integrated with SQLite for user authentication and interaction. The Flask web interface allows users to enter the names of movies they have enjoyed or are interested in. These movie names serve as the user's preferences. So the system then processes these movie names to align with the format of the dataset. It extracts relevant features such as genre, cast, director, and synopsis from the dataset for the inputted movies. Using cosine similarity, the system calculates similarity scores between the features of the inputted movies and those of other movies in the dataset. Based on these similarity scores, the system recommends movies that closely match the user's input. The recommended movies, along with their similarity scores, are displayed to the user through the Flask web interface. Users can explore and view these recommendations to find content aligned with the preferences, improving their movie watching experience. Overall, the project builds a Netflix movie recommendation system using content based filtering and cosine similarity. It integrates Flask with SQLite for user interaction, allowing personalized suggestions based on user preferences. Users benefit from tailored movie recommendations, enhancing their experience and increasing engagement. The project also provides insights for developers into recommendation techniques and web framework integration. So, this is what we are doing in this project. Now, we'll look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll see the execution. Before executing the project, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is static folder which consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is Netflix titles dataset file. So I have already opened it in Excel. So this dataset, the name of the dataset is Netflix movie dataset. It contains details about Netflix movies such as unique identifiers, title, director, release date, rating, duration, description, genres, edition dates, etc. So the dataset provides a comprehensive overview of each movie's attributes, enabling analysis like recommendation systems, content classification, and trend identification. So we will be training the techniques on this dataset. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So it stores information like user sign up details. This is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path, I'm copying it. Open Anaconda prompt. So we can see it is locating to the C drive. We have the code folder in the D drive. So use the command D colon to change the drive location. Now use the command cd followed by a space and paste the copied path of the code folder. Now hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a sign up link, click on it. So if we are new users, we have to register ourselves first. Fill in all these details and click on sign up button to register. If we already have account, we can directly log in by clicking on this login link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So here we can see a box where we have to provide movie title as input to the application. The system analyzes these titles and generates movie recommendations based on their characteristics like cast, duration, synopsis, etc. By processing the inputted movie title, we receive personalized suggestions for movies we may enjoy watching. So I'm giving the movie name as City of Joy. Now click on submit button. So here we can see the recommended movies based on the inputted title along with their similarity scores. So these are the recommended titles and these are corresponding similarity scores. So the similarity score indicates how closely each recommended movie matches the inputted title. So these are little similar movies to what we have entered. The people who watched City of Joy may also enjoy these movies. So these are the recommendations. Click on home. We'll try giving another title. I'm giving it as Wake Up Sid. Now click on submit button. So here we can see all the recommendations and corresponding similarity scores. So people who watched Wake Up Sid may also love to watch these movies. Click on home link. We'll try giving another movie name. I'm giving a show name this time, Friends. Click on submit button. So here we can see all the recommendations and we can also see the similarity scores here. So these are little similar movies or shows to what we have entered, the input which we have given. So the people who watched Friends may also enjoy these movies or shows. PK, click on submit button. So here we can see the recommended titles: Three Idiots, Sanju, Chaldhar Pakhad. So these are a little similar movies to what we have entered. that is PK. So the people who watched PK may also enjoy these movies, and here we can see the similarity scores. So in this way, we can enter any movie names from the test cases we have and can get the recommendations, movie recommendations. So I'm giving it as race. Click on submit button. We can see these are the recommended movies. Race, Two Players, Phantom, Tal. We can see the similarity score here. We'll try with one more. I'm giving it as dark. Click on submit button. So we can see these are the recommendations. For the movie which we have entered dark. So these are a little similar movies to what we have entered. The people who watched dark may also enjoy these movies. Now click on sign out. So the project successfully implements a Netflix movie recommendation system using content-based filtering and cosine similarity. Integrated with Flask and SQLite, it provides personalized suggestions based on user input. Users receive tailored movie recommendations, enhancing their experience, while Netflix gains increased engagement. Developers gain insights into recommendation techniques and web framework integration.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.